Welcome to ToKCast and to part 3 of things that make you go, my exploration of thematics, morality, multiverses, as this one will be about metaphysics and many other things that are covered in the conversation between Max Tegmark and Sam Harris. As I keep saying, it's a wonderful conversation. Go looking online for the podcast. If you sign up as a member of Sam's community, then you get access to the entire podcast, which is what I've got access to. Or you can buy the book of conversations, which includes the conversations with David Deutsch. That's part 1 of the book, and there's an audio version of it. And Max Tegmark as well, which is the very last part of the book. So as I said before, 2 great thinkers to begin and end a journey through the Making Sense series. Today, this one is about multiverses. Now, I've got an entire series online about the multiverse. The multiverse, as I understand it, what we know exists is what is known as the Everettian Multiverse, the quantum multiverse, the multiverse that is explained in the fabric of reality and the beginning of infinity that quantum physicists talk about. So it is said an interpretation of quantum theory. We don't regard it as an interpretation any more than one would say dinosaurs are an interpretation of fossils. In a sense they are, but there is no other viable interpretation. Now, of course, many quantum physicists will disagree with this kind of thing and say, oh no, they don't endorse the multiverse. Now, sometimes this means they're an instrumentalist, in which case they're not endorsing any particular interpretation. They are retreating from interpretations full stop, and hence explanations full stop. They're only interested in predictions, so they say, so they claim. And I would just say of that, it's completely irrational, because you need to understand what you're doing. Simply being able to predict the outcome of experiments is not understanding and explaining reality. And even if we don't have a perfect explanation of reality, your job as a scientist should be, at least in part, to try and understand reality, to give us the best explanation. That's one thing. Other physicists who deny the reality of the multiverse and try and come up with their own version, what they end up doing when you look at the details, something like Bohm's pilot wave theory. I've read quite a few interpretations over my time. Paul Davies has that wonderful book, Ghost in the Atom, where he goes through a large number of interpretations. There's been a few popular science books written recently, well, I think they get written every other year, about, some physicist's pet favourite interpretation, one they've made up. Well, these all fall into 2 categories. They're either going to be of the instrumentalist bent, where they're just denying that you can have a proper interpretation and so just calculate. That's one way the popular scientists do it, and the physicists. And the other is just to disguise the multiverse in some way, shape or form. It's the multiverse in heavy disguise, as David Deutsch likes to say. What happens is they postulate the existence of things you can't observe. In other words, physical reality, the reality we inhabit and the reality we have access to in a sense directly, is being impinged upon by other entities in reality that we can't observe. So these other entities in reality, although these physicists and these popularizers of science might say things like, I don't endorse the multiverse, I think that's a proliferation of universes, it violates Occam's razor, or it's just crazy metaphysics or whatever. Nonetheless, their own interpretation tends to invoke the existence of stuff you don't have experimental access to in quite the same way. You have to infer its existence. And all we say about that is, well, yeah, you're inferring the existence of stuff. Okay, that other stuff occupies a different space. It's not here now, but it's having an effect on the stuff you do observe, the stuff you do see. You're explaining why you get interference effects because something's affecting the path of those photons or those electrons or those particles. Something that you can't see, but you're saying it really exists. That's the multiverse. Now, you can call it whatever else you like. You can call those other things by Christian names if you prefer. But the fact is, they exist. You're saying that other stuff exists, and that's what we say the multiverse is. Now, we have a richer explanation, a coherent explanation that just says, well, for each particle you do observe, there are counterparts of that particle, fungible instances which can differentiate themselves and thereby cause interference. So whatever the case, this is the Everettian multiverse, which, as I say, it's unusual in that Max Tegmark does endorse a version of this, but it's the one kind of multiverse that is not talked about really. It's not really referred to here in the Making Sense podcast with Max Tegmark. So a lot of this part of the conversation between Sam and Max, I'm skipping past. In fact, I've missed an entire bit, and I'm not going to talk about it at all, where they do discuss information and its relationship to mathematics. I'm going to skip over that. And here as well, I think I can skip through a lot of the multiverse stuff, because if you go back to part 1 of my treatment of this conversation, what you will see there is that I basically summarized the 4 levels of multiverse that Max endorses in some way or other, and I talk about it there. So I won't go through that again now. I'll let Max just speak, and then he moves on to the simulation hypothesis, and I'll have a few things to say about that. So let's get into the discussion today.
I now want to get into the multiverse, which is probably the strangest concept in science now. It's something that I thought I understood before picking up your book, and then I discovered there were 3 more flavors of multiverse than I realized existed. I want to talk about the multiverse, but first let's just start with the universe, because this is a term that around which there is some confusion. Let's just get our bearings. What do we mean, or what should we mean by the term universe? And I want to start with your level 1 multiverse. So if it's possible, give us a brief description of the concept of inflation that gets us there.
Sure. So what is our universe, first of all, before we start talking about others? Many people tacitly assume that universe is a synonym for everything that exists. And if so, by definition, there can't be anything more. And talk of parallel universes would just be silly, right? But that is, in fact, not what people generally in cosmology mean when they say universe. When they say our universe, they mean the spherical region of space from which light has had time to reach us so far during the 13.8 billion years since our Big Bang. So that's, in other words, everything we could possibly see, even with unlimited funding for telescopes, right? And if that's our universe, we can reasonably ask, well, is there more space beyond that, from which light has not yet reached us, but might reach us tomorrow or in a billion years? And if there is, if space goes on far beyond this, if it's infinite or just vastly larger than the space we can see, then all these other regions, which are as big as our universe, if they also have galaxies and planets in them and so on, it would be kind of arrogant to not call them universes as well, because the people who live there will call that their universe.
Unfair or misleading in a way. You see, Max defines into existence there something that, as someone who trained in astronomy, and far be it from me to quibble with a world-renowned cosmologist, but what I was taught throughout my degrees in this was that we know, as a matter of Big Bang and inflation cosmology, that of course there is this thing, the observable universe, which Max defines quite rightly there as the region of space where light has had time to reach us. But we know, as a matter of fact, that that's not all of space. That continuous with that, and continuing to expand, is space beyond that. Continuous with that, it's just that the light hasn't had time to reach us from that particular region just yet. So you can go all the way to the deepest recesses of space. I don't know how far it is, 40 billion light years away. By the way, it's further than 13.7 billion light years because of inflation, because of the expansion of the universe. So from here to the furthest away possible is something like 40 billion light years, whatever, this spherical region of space. But we know there's space beyond that. The theory tells us that. And then in fact, because space is expanding at those furthest, farthest reaches faster than the speed of light, and space can expand faster than the speed of light, Einstein's theory of relativity says you cannot move through space faster than the speed of light, but space itself can expand faster than the speed of light. So there are galaxies there at the edge of the universe which are moving beyond, being expanded beyond what we can see. So that might be visible today, but cannot possibly be visible tomorrow because they've disappeared beyond the horizon of light where light can reach us. So we know this is going on. This is a matter of science. This is a matter of normal science. So this is why generally when this kind of material is taught to students of astronomy and cosmology, they're taught, so therefore you've got this observable universe, this ring, and then out of that is another concentric ring, concentric sphere would be more precise, of a region of space perfectly continuous with that, which contains galaxies and planets and all that other stuff, all the stuff that we see, but it just goes on even further, beyond what we can see. So that's all the universe, okay? So the physical universe is that thing, and that's usually what astronomers, astrophysicists, cosmologists refer to as the universe. And they distinguish that from the observable universe. And that's why, to be honest, it's just idiosyncratically Max Tegmark, as far as I'm aware, who refers to this as the level 1 multiverse. So it just seems a bizarre way of confusing people, and people already object to the idea of multiverse. But so it's a little off-putting, which is why, people just talk about the universe, just everything that exists. Some stuff that exists we can't see, and we've talked about that ad nauseum on here. So this is why I say level 1 multiverse, I don't know if it counts as a multiverse. It's more like just the universe. And the strange thing is, Max concedes as much himself soon in this conversation. He just says, well, the level 1 multiverse, that's just another way of talking about space. Space. So the only reason for the term here seems to be to distinguish between the region of space that's observed or observable in principle and the region of space that is not observable in principle. But if that's the criterion, a spatially connected region that's not observable in principle, scientifically, well, it's the core of a typical star, another universe in some sense. Is the innards of a black hole another universe in some sense? Well, of course, some cosmologists might actually argue that. Or the innards of a neutron star then, not observable in principle. We don't have any good explanation about how you would even go about beginning to build an instrument that would be able to get there. Another universe? No, I think this is misleading. This is just an unnecessary use of a term which should be used precisely. And in science, we want precision with our terms, to the extent that we can get precision. Yes, everything is ambiguous and all that sort of stuff, granted. We should try and have an economy of terminology, especially precise scientific terminology. I think it just degrades things if we just start throwing the words around everywhere. All right, I've made enough of a point on that. We'll come back to it again shortly. Let's keep going anyway.
And inflation is very linked to this because it's the best theory we have for what created our Big Bang and made our space the way it is, so vast and so expanding. And it actually predicts generically that space is not just really big, but vast, and in most cases actually infinite, which would mean, if that's true, if inflation actually happened, that what we call our universe is really just a small part of a much bigger space. So in other words, space then is much bigger than the part of space that we call our universe. And this is something actually I don't think is particularly weird once one gets the terminology straight, because it's just history all over again, right? We humans have been the masters of underestimation. We've had this the overinflated ego where we want to put ourselves in the center and assume that everything that we know about is everything that exists. And we've been proven wrong again and again and again, discovering that everything we thought existed is just a small part of a much grander structure. A planet, solar system, a galaxy cluster, our universe, and maybe also a hierarchy now of parallel universes.
So Max is, of course, quite right there about the history, and it's a point I've made here on ToKCast many times before. The history of science, the history of physics, cosmology in particular, astronomy, is this history of gradually our understanding becoming ever larger of stuff. Our understanding. And so we used to think it was just basically planet Earth with celestial spheres, and we didn't know what they were. But then we figured out we actually occupy this thing called the solar system, which is bigger than the planet. And we realized, well, the solar system is actually inside this thing called the galaxy. Oh, the galaxy, well, it's just one among many galaxies. We've got this whole thing called the universe, and well, it shouldn't be much of a surprise that we have this multiverse. Now, the only sense in which I disagree kind of with Max here, I think, is that the proper epistemology allows you to distinguish between what's known, in the sense of having a good explanation, a solution that solves a particular problem and no longer has any rivals, and so therefore you say it is the explanation of something, and competing hypotheses where you don't really know and you don't even have a method of being able to test for these things just yet, and you can't rule out the alternatives. That's a key thing. You can't rule out the alternatives just yet. So you can't say you know these things. So these are not all on equal footing. These levels of multiverses are not on equal footing for that reason. But the way that Max talks, it's as if they're kind of, these all exist. And, you buy one, so why won't you buy the other ones? Well, because some of them are well-known good explanations that solve a particular problem. Because that level 1 multiverse, which I just, again, insist on calling the universe, it solves a particular problem. It enables us to explain observations of the actual universe that we have in cosmology, like the cosmic microwave background, like the ratio of hydrogen to helium that we observe out there in outer space, like the expansion, the redshift of galaxies, the expansion of space. So it solves these things. So the dark night sky is another one. So this is solved by postulating an expanding universe, and a universe therefore beyond what we can actually observe. So that solves the problem. The Everettian Multiverse solves the problem. It's like, how do we explain the observations of things like interference experiments? Everettian Multiverse. We need to invoke the existence of these parallel other universes that contain fungible instances of every single particle. Okay, so that's that. But then when we get into these other ones, these level 2 multiverses, and especially level 4 multiverse, they are hypotheses that don't yet count as good explanations. Why? Well, because in the case of, let's take level 4. The level 4 multiverse is this idea that all different physical laws exist out there somewhere or other. So all the logically possible universes are out there somewhere or other. Now, the overwhelming majority of those are governed by physical laws which are completely hostile to life. So why would you think this thing up? Well, one reason you would think up this plenitude, these other universes with other physical laws, is to solve the problem of why the constants of nature here in our universe appear to be finely tuned. Now, I think the fine-tuning problem is a problem. But there is a debate in physics between physicists, some of whom say, well, it's not a problem. But here's the thing. We don't know the answer to this fine-tuning problem. We don't know why the constants appear to have been finely tuned to allow for life here in this universe. Change any of the constants, Max will come to this, and you won't get life. Change them by too much and you won't get life. But here we are. It seems a remarkable coincidence that conditions are just right. We're in the Goldilocks zone, not only for one constant, but for all the constants. That's remarkable. It's a remarkable thing. One such solution is, well, you've got this multiverse of all the other universes with different physical laws, most of which don't have life. So why should we be surprised? If all the other universes are out there, of course, we're going to find ourselves in the one that is very bio-friendly. It's friendly towards life and intelligence. Okay. Now, truth be told, you don't even need level 4 for this. You just need Max's so-called level 2 multiverse, which he's coming to shortly. But he switches between these things pretty fast in this conversation, so sometimes it's hard to keep track. Level 2 is just the class of universes defined by all solutions to string theory, or something like that. Whatever, all our physical constants, they still exist in those other universes, but they take on all possible values somewhere or other in that multiverse. But presumably quantum theory and general relativity, they still hold, or string theory still holds. So the laws themselves are the same, the form of the laws, but the constants are not. So this is one way of arguing about fine-tuning, and one way of solving, in scare quotes, the problem of fine-tuning. We find ourselves in the universe, or in one of the small number of universes, where the constants are just right, and all the others actually exist out there somewhere or other. Of course, you could have wildly different constants and wildly different physical laws, making a bio-friendly universe, and then you might get life. But that's level 4. Indeed, in level 4, you might not even have constants at all. Who knows what goes on in level 4? You just have every logically possible universe, every logically possible thing. In some, magic really does work. The Star Wars universe is actually out there, literally real in this level 4 universe. Universes violating conservation laws, and universes where you can go through space faster than light, ad infinitum in every single sense there. That's called the plenitude. David Lewis wrote a book, like I said, about this. And this, by the way, makes the plenitude easy to vary. The plenitude, all logically possible universes, or what Max calls the ultimate ensemble, anything that, in his mind, is even conceivable. But I would say, actually, conceivable is too limited a word for this. Maybe what is inconceivable still exists and still counts as possible. Why is our ability to conceive it a constraint on what logical reality is as a whole? I doubt we can get agreement on what counts as conceivable or logically possible. Is God, the Christian God, logically possible? What about Zeus? What about other creator gods? If they're logically possible, if they obey logic, then they exist out there somewhere or other and they're creating universes. and presumably our own too in an infinite number of universes. Or if these gods are not logical, never mind physical, then what is logically possible? And are other logics permitted in these other logically possible universes? After all, what we consider logical is what is knowable to us as logical in this universe, obeying these laws of physics. Perhaps in other universes with other laws of physics, they can compute stuff which includes coming to know things that includes an understanding of a logic deeper than ours or different to ours. This is quickly becoming mind-bending self-referential stuff. Illogical, perhaps. So, whatever the case, maybe then Yahweh doesn't seem so strange to you now. Maybe the Hindu gods don't seem so strange anymore. By any measure, the plenitude, the level 4 multiverse, is far stranger because it includes Yahweh and all the Hindu gods and every other set of gods that you like who created our world. Whatever the case. These multiverses are argued for on the basis of fine-tuning. It's the only reason I ever see them being invoked. But, well, aside from in purely philosophical discussions, but they only come into physics in this particular way, by trying to solve fine-tuning. But fine-tuning remains a problem still, because many physicists don't agree with this particular solution. And quite right too, because as I say, it's not a good explanation. I don't think this solves the problem. Most don't think this solves the problem by this explanation. It's not a good explanation. It's too easy to vary. But in fact, so are the alternatives to it. These multiverses, especially the number 4 multiverse, they're easy to vary. Like, people will vary on what is conceivable or logical or possible in that way because they're not constrained by physics. They're not even constrained by imagination. And maybe level 4 consists of the infinite class of logically possible universes, but just not the one where the electron has double the value of what it does in our universe. I mean, that's a logically possible multiverse, right? So that's easy to vary. Maybe they all exist except for that one. Or they all exist except for that one and where the electron has a charge of triple ours. Ad infinitum, as I say. Anyway, there are at least 2 other competing theories for this, okay? That's a wild claim. Every possible reality exists out there somewhere. Pretty wild claim. I think it's less wild, to be honest with you. I think it's less wild to postulate the fact that a God created this universe. A God created this universe. Now, why is it less wild? Well, because if every logically possible universe exists out there somewhere, that includes universes created by gods. Universes created by gods. So if you postulate every logically possible universe, logically possible, not physically possible, logically possible, it's logically possible that you can have all-powerful beings that are out there somewhere or other. It's logically possible. I can imagine it. If you can imagine, it's logically possible, right? I don't see a contradiction in that. Other people are going to say, oh, it is a contradiction. Okay, well, let's have something lesser than an omnipotent, okay? But godlike beings are out there. For all intents and purposes, godlike beings occupy that multiverse. So isn't it more parsimonious to just say, rather than have an infinite number of godlike beings, let's have one godlike being that created this universe? Seems more parsimonious. Anyway, so these are 2 of the competing claims. Now, there's at least a third I know, which is that the physical laws here are biofriendly, and we appear the way that we do because it's mathematically necessarily required. And whatever the successor to quantum theory and general relativity is, or the successor to the successor of that, will turn out to just have a set of equations which require, as a matter of mathematical necessity, logical necessity, that the constants have the values that they do. And so if this is the case, well, that rules out the plenitude, the multiverse of multiverses, so to speak. We don't know, but the way that some popularizers, some people in this very conversation are talking, it's as if that level 4 multiverse, it counts just as well as the level 1 multiverse and the level 3 multiverse. And I just don't think that it does. I don't think that it does. We're not distinguishing between these different kinds of universes, multiverses rather, in the way that we should. What is known, not known to be true, but known as our best explanation, known to be a good explanation of the observed facts, and what is just one of many competing hypotheses that you would invoke a multiverse for. But there could be other solutions that rule out, that refute that multiverse. So we're going to pick it up where Max begins to talk about inflation theory, which is interesting. I'll have some things to say about what he says about inflation theory here. And also his own sort of, well, walking back to a certain extent of what this level 1 multiverse, in scare quotes, happens to be. So let's hear what Max has to say.
first, it's a great illustration of one of the cool things in science, where you start with some pretty innocent assumptions, namely here that space just goes on forever, like most of us thought as kids, and moreover that things started out a little bit randomly everywhere, and you get this totally shocking conclusion. If when I go ask my colleagues, I would say the vast majority of them would put their money on that some form of inflation happened, and that our space is actually much bigger than our universe. Whether it's actually infinite or just really huge starts getting a little bit more controversial, and we would love to we also don't know for sure, of course, whether inflation actually happened. But this is sort of the simplest version of the theory, where space simply goes on forever. It's an infinite space, much like Euclid's space, or the one we thought about as kids. And in the book, I call this the level 1 multiverse, but you can just use the synonym space for it. And just to drill down a little bit more on where the craziness comes in, if you look at the way our universe got this way and the way our podcast came about, right, it's because we had about 10 to the power 78 quarks and electrons here that started out in a particular way, somewhat random early on after inflation, which led to the formation of our solar system and our planet, and our parents met and so on, and we met, and then this happened, right? If you'd started the quarks out a little bit differently, things would have unfolded differently. And you can actually count up how many different ways you can arrange the quarks and electrons in our universe. And it turns out it's only about a googolplex different ways, where googolplex is one with a Google zeros and a Google is one with 100 zeros. So it's a huge number, but it's finite. So if you have an infinite number of other regions equally big, and you roll the dice again, and all of them, then as you can calculate that if you go about a googolplex meters away, you will indeed end up with just what you described, a universe that's extremely similar to this one, except that 1 minute ago, you all of a sudden, decided to start speaking Hungarian instead.
So there's 3 things I want to say about what's just been said there. The first is that Max says that you can't know for sure about whether or not inflation is actually the explanation of the beginning of the universe. And as we say here, well, if that's your standard, knowing for sure, then you won't know anything at all. Now, inflation is an interesting kind of an explanation. I would say we know the Big Bang occurred, and I would actually also tend in the direction of saying that we know inflation happened as well. I just don't think there are any other viable competitors at the moment. We need to explain observations of stuff like the cosmic microwave background. Now, the cosmic microwave background has this feature of being exceedingly smooth. And what exceedingly smooth means is that when you map these slight temperature variations in the empty space between galaxies, this is the cosmic microwave background radiation, the heat left over, the residual heat left over from the Big Bang, well, actually, you look far enough off into the distance to about 300,000 years after the Big Bang, and you get this map. You get this map of the sky. This is what COBE, the Cosmic Microwave Background Explorer, and WMAP, the Wilkinson Microwave Anisotropy Probe, and recently the Planck Telescope. These satellites that are up there mapping this cosmic microwave background. Whatever the case, what we find is that it's about 2.7 Kelvin. This is 2.7 degrees Celsius above absolute zero. But there are fluctuations in the temperature. Slightly warm in this region, slightly cooler in this region. But those fluctuations are so small that the smallness of the fluctuations cries out for an explanation. Because the quantum cosmologists say that, well, when the universe was smaller than an atom, then there would have been these fluctuations. The fluctuations should have caused greater temperature differences if you just rely upon classical Big Bang theory. The regular Big Bang theory should have magnified these temperature differences. But instead, we don't see these huge temperature differences. We see very small temperature differences. So why are there small and not huge temperature differences? Well, inflation theory explains that. And we have no other explanation, as far as I'm aware, of why it is that we observe what we do. So we've got this observation that cries out for an explanation, and we have only one explanation. Now, if someone comes up with a rival, then we would need to have a crucial experimental test that could decide between the theories, but we don't have any other theory. So the only known explanation for why we're getting this smoothness in the cosmic microwave background, amongst other things, by the way, you can go Googling or Wikipediaing inflationary cosmology, the inflation theory, which is just a version of the Big Bang theory. And what you learn is that there are observations that are explained by inflation theory, but not explained by anything else. And so this is important. So this is why I would say it's quite right and reasonable to say we know inflation happened. As we know the Big Bang happened, as we know evolution by natural selection happens. These are the only known explanations of the observations that we have. Now, do we know these things for sure? No. Again, if that's your standard, well, you're always going to be disappointed in science and everywhere else. Notice also that there Max admits what I was complaining about earlier, which is that this level 1 multiverse, not really a multiverse. He just says there it's a synonym for space. Quite right. I think that's quite right that he should say that. But then he also says a thing that I might quibble with just a little, which is that if we have this finite amount of matter, but it can be rearranged into a finite number of different arrangements, nonetheless, this means that because there's such a stupendous number of different arrangements that we could have, that we would have all possible arrangements represented there somewhere or other. I don't know that that follows. I don't know that that falls out of the way in which the physics actually works. Unless, of course, you're talking about the Everettian quantum theory, where, yes, indeed, there will be versions of you that are very similar to you and versions of you that are very different to you. But this idea of traveling physically through space to reach another planet, for example, where there's someone very similar to you there, I don't know that that follows. We would need another physical law that mandates that all the different possible arrangements really would be represented out there in deep, dark areas of our universe somewhere or other, in other spatially connected regions too, the one that we occupy here. I don't know that it follows that you're getting something like the Everettian multiverse here in our regular physical universe, just at a great distance from us, which is what he's talking about here. It very well could be that distant regions of the universe have subtly different physical properties to what is had here. Because of just quirks of the Big Bang, for example, quirks of the Big Bang could distribute the matter in different ways. And so it could clump together in different ways. And this would mean that not all clumpings are going to lead to what we see around us in our region. They might all collapse together into a black hole in some of these places. It might spread out into a vacuous nothingness. There's nothing that says that the kind of multiverse he's talking about here needs to represent all possible configurations of matter. That just might not happen. Unless there's a physical law that says, well, yes, this kind of thing happens. But I know of no such physical law that mandates this. This is in the realm of the unknown. It's a form of metaphysics, as I say. It's a stepping outside of science. I don't know how we could test this exactly yet. Let's keep on going.
It's a very mind-boggling idea. We don't know for a fact that it's like this, but this is the sort of the vanilla-flavored cosmological model, the one that is the most popular today.
Right. Well, and I think the weak link in this chain of reasoning here, or the place where a skeptical person can get off this train, is in the assumption or belief that inflation implies an infinite universe rather than just a very large one. And so it seems like you could pull the brakes there. But unfortunately, this concept of a multiverse, judging from your discussion of it in your book, and this is what I didn't understand before I picked up your book, seems overdetermined. It seems there are other ways at arriving at this multiverse concept, which we'll get to. And so it has scientifically speaking, there are many reasons to believe in a functionally infinite number of copies of ourselves living out lives of, for all intents and purposes, exactly similar or differing to every possible degree, right? So it's true to say that everything that can happen does happen under this rubric.
That's right. So just to distinguish between what we know and what we don't know for sure, the part that we don't know for sure is that space is infinite, or that there's an infinite number of anything. And for people who feel really bothered by these implications and want to get rid of the infinity. In fact, I have a whole section in the book where I attack infinity and list all the ways in which you can get rid of the infinity. So there's a lot of interesting opportunities there, and we're going to know more, I think, in the next 5 or 10 years. However, what I think seems pretty much inescapable at this point is that their ultimate the full reality is at least much larger than what we can see. There's just no way that space ends exactly at the edge of our universe. In fact, if you had made that claim, 1 minute ago, I could falsify it now by looking with a telescope, because I can see light that's traveled from 1 minute farther away. And that's pretty far. That's a sixth of the way to the sun, an eighth of the way to the sun already, right? And so we should probably get used to the idea that we live in a much grander reality than we thought we did. And I think that's a good thing.
Yeah.
Frankly.
Oh, yeah. No, so I don't think people's intuitions recoil at the very, very large, or even I think people are prepared to embrace the infinite and the eternal in some sense, even though we could debate whether thinking about a beginning is actually more understandable than thinking about an eternal universe, given how squirrely the beginning begins to look. But I think what really will blow the mind of anyone who thinks about it long enough and seems very difficult to accept is this idea at the level 1 multiverse, what is implied by just the sheer concept of infinity, that everything that is possible is in fact actual. On some level, everything is true. And let's just spell out why this should be disturbing and why this may in fact be, at least at first glance, a real embarrassment to science, because science prides itself on being parsimonious.
Well, no, it's not the case that the level 1 universe, in any way, shape or form, says that everything that's possible is true. I don't get that everything is true in some way, in fact, I think he said. There's an ambiguity about what that would mean anyway. Do we mean everything that's physically possible is true, or everything that's logically possible is true? Well, it can't mean the last thing, which is the level 4 multiverse. So the level 1 multiverse, which is just space, even if space was infinite, that doesn't even imply that everything physically possible would be true. It doesn't imply that at all. I could readily imagine an infinite space where we occupy a region which is different to the rest. You'd need to have a particular kind of what's called the Cosmological Principle, which says that there's nothing particularly special about our particular region of space. But if we don't have access to these other regions of space, this other infinite region of space, we could easily postulate other regions of space which are empty, for example. You'd still have infinite space, or you could have an infinite space beyond what we can see that is filled with nothing but hydrogen nuclei, which is protons. That would be basically a featureless universe. But the thing is, if we can't observe, and if we don't have good explanation of, at this point, what this infinite space is like, then you're just postulating a particular metaphysics once again. Saying that somewhere off in this infinite space, there must be every single physically possible thing represented there in some way, shape or form. But I don't see that follows. If all you're saying is it's an infinite space, even if you said it's an infinite space like ours, that doesn't mean that you're going to eventually get an Earth just like ours here. You have to add extra assumptions to this idea. The extra assumptions being, well, you've got the same kind of distribution of matter out there in infinite space. But that's a very specific assumption that you're making. And it's ruling out all the ways in which you don't have the same distribution of matter elsewhere. There's something very special about the Earth, after all. Just look around. It's unusual. The universe, vast as it is, may only contain one Earth. Of course, infinity tends to sort some of these things out for you. But the level 1 multiverse, I'm not so sure. And certainly it would not imply all logically possible realities out there somewhere. That certainly doesn't follow. Okay, Sam and Max then go on to talk about parsimony, okay, which is basically Occam's razor. This idea that all else being equal, we should choose the simplest explanation. This was why, when I asked Professor Paul Davies why didn't he endorse the multiverse, the Everettian multiverse, when I had the chance to talk to him about this, he appealed to Occam's razor. He said, well, in order to explain the one universe we do observe, we're invoking the existence of an infinite number that we can't observe. And at the time I bought it, of course, now I realise, no, Occam's razor is about the number of independent assumptions that you have. And, the multiverse, the Everettian multiverse, has no real additional assumptions being added on to the formalism of quantum theory. It's just saying, well, take the equations seriously, take them literally, take the results of the experiment seriously, and this is all you get. You don't need to add anything about consciousness and the observer or anything else. Everything just obeys the same physical laws. And so therefore you have all matter obeying the same physical laws. And the equations describe the existence of these other things. And it also explains why you won't observe these other things. You can't communicate between universes, for example. So they quite rightly point out that parsimony, or recourse to the simplest theory, Occam's razor, however you want to describe this, is not a reason to object to multiverse theories in general, and certainly not a reason to object to the Everettian multiverse. But once again, they're kind of dancing around the Everettian multiverse. They never get there and talk about quantum theory, which is a shame. The one really interesting, by virtue of the fact of being an explanation that is unusual, but also, so far as we can tell, it's the correct one. It's the right one. So I'm going to skip through all of that because I think listeners to ToKCast, readers of the Fabric of Reality, for example, know about Occam's razor and parsimony and this kind of thing.
Let's press on into the multiverse to level 2. This will push people's intuitions in the direction of feeling like, at the very least, we're trying to have our cake and eat it too on this question of parsimony. So take us to the level 2 multiverse and perhaps say why this is relevant to the question of fine-tuning, and the question of fine-tuning, as many people will recall, is relevant to this idea of that many religious people have of why religion, the idea of a creator God in particular, makes sense given the apparent fine-tuning of our universe.
With pleasure. So the level 2 multiverse, you can again synonymously call simply space, if you want. Inflation is able to actually not only make an infinite space, but it's actually able to make fit within this an infinite number of regions that each seem infinite to whoever lives inside of them, through some very, very weird properties of Einstein's gravity theory that I talk about in the book. And what's interesting about this is that when you ask how diverse is space, you might think, in some places our podcast goes like here, and other places we talk about other things, but at least the laws of physics are the same everywhere. You might think, at least even if people learn different things in history class, if the Sam Harris somewhere else learns different things in his history class because the quarks started out differently there and history played out differently, at least he's going to learn the same thing in physics class. But the level 2 multiverse changes that also, because it turned out that a lot of things that we thought were fundamental laws of physics that were true everywhere in space were actually not, it seems. And I like to think about it as if I were a fish swimming around in the ocean. I would think that it's a law of physics that water is something you can swim through, because that's the only kind of water I know, and it seems to be that way everywhere I look. But if I could solve the equations, discover the equations for water, and I could solve them and see that there are actually 3 solutions, not one. There's the water solution and also ice and steam. Equivalently, there are a lot of hints now in physics that what we call empty space is also like that it can freeze and melt and come in many different variants. And the thing is, inflation is so violent that if space actually can be in many different forms, what inflation will do is it will create each of those kinds of space, and an infinite amount of it at that. So if you go really, really far away, you might find yourself in a part of space where there are not actually 6 kinds of quarks like there are here, but maybe there are 10 kinds of quarks. So the level 2 multiverse is very, very diverse. Also, a lot of things that we learn in school are fundamental parameters of physics. For example, that the number 1836 seems kind of hardwired into our world, in that the proton is 1836 times heavier than an electron. Why is that? Well, string theory suggests that actually that's one of those things that also changes depending on what kind of space you have. So it might be 2015 somewhere else, and 666 somewhere else. And this explains this fine-tuning problem that you mentioned, because we've discovered, as I alluded to earlier, that there are these 32 numbers, pure numbers with no units or anything that we've measured, that we can use to calculate everything else. And we wonder a lot about where they came from.
So these are the constants of nature. Could you just list a few of them to give people a sense?
Yeah, so 1836 is one of them. how much heavier a proton is than a neutron. You can transform them in different ways. Another one which is super talked about these days is the density of dark energy.
Okay, so as I explained in episode 1 of my discussion of their discussion, the level 2 multiverse is a version of the multiverse where it's presumed that the initial conditions are somewhat different. And indeed, the constants of nature are somewhat different. And this arises out of, as Max is explaining there, versions of string theory. Now, we don't know, this is a kind of metaphysics as to whether or not such universes exist. But we're still within the realm of, although he insinuated there that the laws of physics are different, not really. We still have, although we might have different numbers of quarks in these other universes, we still have quarks, for example. We're still bounded by what string theory says is possible. So we're not yet in the realm of all logically possible universes. We're not there yet. But we are saying, well, you can vary the constants of nature, let's say. But we still have constants of nature. Those constants of nature still exist. And so perhaps we can explore the space of all different constants of nature. Now, this is actually done by some people. Some people, this is their job. Cosmologists. Luke Barnes, who is easily found on Twitter, is one of the people I follow on Twitter. He's a cosmologist at the University of Western Sydney. He works with Geraint Lewis, who is an astrophysicist at the University of Sydney. They've written books on this, or they've written at least one book, called A Fortunate Universe. Now, there have been many books written on this idea of fine-tuning. Some people disagree with fine-tuning. I buy it as being a problem. Why is it that we inhabit a region of space where the constants are what they are? We don't know yet, and as I've already explained, it could be that we have this multiverse of universes where all the different constants of nature are out there represented somewhere or other. Okay, that could be the case, and we, of course, occupy the one where the constants are just right. And there are many other universes kind of like this as well. Well, the work of Luke Barnes, among others, sort of suggests that this fine-tuning is very, very fine-tuned, and we need an explanation for this. Many people say we don't need an explanation for this. Now, Barnes, for one, thinks that it's a very poor explanation to say, well, it's the multiverse that explains this stuff. And I'll give a link in the information for this podcast and for this episode to his material on this. He does some wonderful lectures. He's also been on Closer to Truth, which is probably my favourite YouTube channel out there. He's been interviewed there. He's an Aussie, and so he has this, to my mind anyway, rather clear way of speaking about this stuff, and no-nonsense sort of way of speaking about this stuff. He's had debates with people like Sean Carroll, and he's had debates with people like Sabine Hossenfelder. So, he's talking to some of the big names out there about all of this stuff, and he really knows his stuff. I mean, he's really across this, and he does things like simulates entire universes in supercomputers to see what happens when you alter these constants of nature, just to see what happens. So it does seem like there's a problem there. It was certainly one of the things that I was most interested in exploring when I was doing formal studies in astronomy and cosmology, was looking into this issue of just how fine-tuned the constants of nature are. Could you change them very much at all? And, well, it turns out you can't change them very much at all. You just the smallest changes to things like the value of the gravitational constant, the strength of gravity, or the value of the mass of the proton. These kind of things, changes in these kind of things either cause all matter in the universe to collapse into black holes, and so you don't get any stars, therefore you're not going to get any planets, or cause a universe where the gravity isn't strong enough in order to collapse matter into stars at all in the first place. And so all you're left with is clouds of hydrogen and helium gas, so you'd have no life in such a universe there either. So that's just a few of the constants. Now, as for all the other constants, well, you can have changes in cosmological constants that cause a ripping apart of space-time very early on in the universe, or even just after the Big Bang, you get an immediate recollapse into a big crunch kind of thing. So this is a very interesting question, open area of research. We don't know much yet. And so this is what they're talking about here with this kind of level 2 multiverse, that maybe all the different constants of nature are out there being explored somewhere or other, but they're still bound by the basic laws of physics. These universes are obeying different versions of string theory. That's one thing. So they're still obeying a certain kind of explanation. Unlike the level 4 one, as I keep mentioning, where you're having every single kind of physical law being. So forget string theory, that's just one tiny sliver of all the possible physical laws that you could have, which is what the level 4 one is. But in neither case do we know, as in to say, we have a good explanation of this as being an account of reality, a reality that we inhabit. So let me skip towards the end of their discussion on the multiverse.
If it's infinite, just suggests that everything that happens, that can happen within the laws of physics, does happen. With the level 2, we're talking about inflation creating an infinite number of bubble universes wherein the laws of physics themselves vary in every conceivable way, and
Let me just interject there, so it doesn't sound too weird. Instead of talking about bubble universes, we can just keep saying space, because there's still only one space.
But
we can't.
But it's not space in a straightforward sense that is.
No, it is actually. But the reason we can never get to another part of the level 2 multiverse is because in order to go there, you would have to go through a region of space which is still inflating and stretching out. So like if you have your kids in the back seat asking, "Are we there yet?" You would say, "Oh yeah, we'll be there in 1 hour." And then a little bit later they ask, "Are we there yet?" And you'll be like, "Yeah, we'll be there in 2 hours."
Right.
So inflation can actually create this funny situation where you have many, even infinite regions of space that are still fitting into one single piece of space. So that's one clarification. It's still just this one space, but messy. And the second thing is, it's not that the actual laws of physics are different. It's just that things that we thought were laws of physics turned out to actually just be different solutions to the laws of physics.
Exactly.
So ice is not the different law of physics from liquid water or steam. They turn out to be 3 different solutions to the equations for water, and that's something Occam would like, because it makes physics itself simpler and it makes history more complicated.
That's a fascinating idea, and it is one that closes the door to this otherwise embarrassing problem of fine-tuning, which is, how is it that we find ourselves in a universe that seems perfectly tuned to support life and intelligent life and beings exactly like ourselves in a position to wonder about these things. And there have been other efforts to close that door just with what's been called the anthropic principle, which you stated earlier, just that the only place we can find ourselves is a place that's compatible with our existence. And so that shouldn't be surprising. And yet it has seemed surprising that essentially that we should exist at all, that the universe could have been an infinite number of ways and it just happened to be this way. Well, according to the level 2 multiverse, the universe is essentially an infinite number of ways, and there are an infinite number of universes that are not compatible with life. It's it's a Darwinian principle of universe emergence, that the only places you can find yourself are the places you can find yourself, and every place that is possible in some sense exists.
Yeah, I don't like the use of the term anthropic principle for these sort of things, because the word principle makes it sound like it's somehow optional. I mean, it's just correct use of logic, which of course is not optional. It's like, why are you really, really surprised that out of all the 8 planets in our solar system, we're living on Earth rather than Venus, where it's 900 Fahrenheit right now, or on Jupiter, where there's no surface to stand on? You're probably not very surprised. I wouldn't call that some deep principle. It's just common sense that the vast majority of our solar system is not very friendly for our kind of life. And the vast majority of space is horrible for our kind of life. And therefore, we shouldn't be very surprised that we're living in a very special part of the space that we can see.
Yeah,
and it's kind of surprised that we're living in a special part of the space we can't see either.
So one way of closing the door to this mystery of fine-tuning, which doesn't entail yet another multiverse, so a level 2 multiverse, is this idea that we could be in a simulation. I don't know if this argument originates with your friend Nick Bostrom, or if other people have. I know other people have arrived at this independently, but
yeah, the argument is older. But Nick Bostrom made a very detailed argument for why he thinks it's actually likely that we live in a simulation.
Right. So I guess we can open the door to that too. So his argument in brief is that if you imagine ourselves in the distant future, or beings like ourselves that make vast gains in their ability to produce computers, and it stands to reason that they will simulate universes and beings very much like ourselves on those computers, assuming that such a thing is possible, and there's really no reason to think it isn't. And then by just dint of numbers, you would expect simulations to vastly outnumber real universes, and therefore you would expect that you should be in a simulation rather than in a real universe. That argument sort of stands on its own, unrelated to this issue of fine-tuning or the multiverse. But if taken seriously, the prospect of being in a simulation, it does answer this fine-tuning argument as well.
So I always want to ask of the simulation hypothesis, what problem does it solve? I don't know that it solves this fine-tuning. There's yet another one. It's just an appeal to the supernatural. But if we do live in a simulation, then that will be revealed to us eventually. People might say, oh, how could it possibly? Well, we would get to a point where a problem would arise that would require us to postulate something outside of the simulation. A simulation won't necessarily have infinite complexity. In fact, nothing can have infinite complexity but reality itself. David Deutsch argues this in The Fabric of Reality. A simulation has to be running on a computer, which presumably is in a genuine physical reality of some kind, computing stuff, obeying the laws of that universe. But the computer that the simulation is running on will have finite memory, finite processing speed. And so we would get to a point where we'd be delving into subatomic particles, what we think are subatomic particles, and just get to the point where we realize or we resolve the individual bits. And this would be telling. This would be telling as to if we got to the end like that, an endpoint like that, then we would have to ask why. And if there was no such answer, we'd have to postulate that this reality exists in another reality, namely a simulation type thing that is causing it to resolve into these fundamental things which can't be broken down any further. I can't imagine what that would be like exactly, but there would come a wall before us when it comes to progress. And that would cry out for an explanation. An explanation that couldn't be within the universe, because the universe, after all, at that point would be bounded, it would be this wall. But we could then ask the question, what's outside the universe? Because we'd get to the end of it in some way. Well, I don't mean the end of it in space necessarily, although that could be a possibility as well. But the end in some way to us resolving stuff, finding solutions. Now, in particular, the smallest particles of matter. There would be a smallest particle of matter, or something the equivalent of that. Some problem would just get solved, and there would be no way of moving beyond that, no way of making progress, unless we postulate something smaller still. But there wouldn't be something smaller still. It would be a strange reality to occupy. So we would be able to find out we're in the simulation. We would postulate the existence of something else on which this simulation is running. And it doesn't solve anything anyway. I mean, because the simulation hypothesis still postulates a fundamental actual reality. So saying we're in a simulation is just to say we're in a thing that's in physical reality, or in a thing that's in physical reality. It doesn't deny the existence of physical reality. And the simulation hypothesis still postulates just more stuff in physical reality, that's all. And the physical reality is something different to what we think it is. But it doesn't mean it's completely and utterly inaccessible. Why? Because we've got universal minds, so we can always guess at what's outside and perhaps do tests and find ways. Who knows, the creative people of the future, if we do live in a simulation, would come up with ideas about how to test this kind of stuff. Anyway, navel gazing, I would say, is this kind of thing. It doesn't solve any problem of ours right now. I've spoken about the simulation hypothesis before, so I'm going to skip past what Sam and Max say on this point.
So, this might be a good bridge, and now I'm mindful of your time here, so we're not doing anything like justice to the contents of your book. We're going to skip over the other ways in which you can arrive at a conception of a multiverse, in particular the quantum mechanical issues addressed by Hugh Everett, and all of that is fascinating, and it's just another route into infinite copies of ourselves, having infinite versions of this podcast, and no doubt in some of those podcasts we treat these topics at much greater length. But I think this is a good bridge to AI, which is where you and I met.
Okay, so there we go. And I would say, unfortunately, Max doesn't get to explain the Everettian view of the multiverse. I like to hear how other people explain that particular good scientific explanation. Max's book is well worth getting on this point. But like Sean Carroll, I think that he mistakes the testability of the multiverse, the Everettian Multiverse, which David Deutsch has, of course, written a paper on. So here at the end, I think it's important just to make some concluding summary remarks. Max Tegmark is, of course, a great thinker, a very good physicist, highly accomplished, and a clear writer of some fascinating topics. However, having read The Mathematical Universe and having heard a couple of interviews with him, what I find is that there is certainly a difference in epistemology, let's just say that, between a perspective that David Deutsch presents in The Fabric of Reality and the Beginning of Infinity, and what you get in something like Max's book, Our Mathematical Universe. And I am going to read a little, just a few short snippets from his book, just to give you a taste of what I mean about this difference between epistemologies and how it comes to affect something like the physics and the conclusions. And importantly, what I would say is the metaphysics, the broader reality within which one's physics sits. One's way of understanding just reality at the broadest possible scale. I think this is why having a good understanding of some epistemology at least clarifies things. Because two misconceptions tend to creep in. The one is, as you would have heard when Max speaks there, and Sam can tend to do this sometimes as well, is that they make a dividing line between knowing and knowing for sure. So he said that phrase at least twice that I recall in the recordings that I made of that discussion. He would say, it's something we don't yet know for sure, but we can't know for sure. Yet he implies we can. But how do we know for sure? We either know something or we don't know something, and that's that. We can just say of these multiverse theories, yes, we know that's the good explanation of what's going on, or we don't know. Yet. And I would say that for what he's calling level 1, absolutely we know. It's part of our knowledge. This is predictive, it's explanatory, it describes what's going on out there in the universe. It is the universe. It is just our explanation of space as we understand it. And the level 3 multiverse, yes, we know it. We know it as the explanation of what's happening in quantum theory. So I agree with Max, possibly for different reasons, but I agree with Max for that reason. Although perhaps we also differ on things like whether or not we know once and for all, we know for sure that these things are true. I would just say we know them. The appending of for sure is a superfluous, unnecessary. In fact, it reduces the meaning of know to something that means it's a useless kind of a word because you never reach this for sure bar. But Max does conflate the two at times, know and know for sure. He wants to say it can't be known until it's known for sure, and it's the sure part that makes it known, and sure means certain, but how can we be certain? The history of science is enough to give us fallibilism, the overturning of previous theories that many people, were certain of at the time. And you also hear throughout the discussion Max making quite a point about this unobserved stuff being a part of science, and Sam agreeing as well. And of course I agree, and David Deutsch agrees, that the unobserved is absolutely a part of science, but Popper continues to be denigrated in some way, as if Popper's epistemology implies that the unobserved is not accounted for because it's not testable within his conception of reality, which is completely wrong. In fact, Popper is the only one who is able to explain how, via David Deutsch I would say, that we get to a knowledge of the unobserved through our theories, via our observations. When you're an empiricist, which so many people are, they say that, well, knowledge is derived from what you observe. And so you're stuck within what you observe. But it is difficult to get a handle on exactly where Max is coming from in constructing knowledge as such. I can't find references to him describing himself as a Bayesian, and certainly he doesn't make a big deal of it in the indices of his books, let's say. You can't find the word Bayes or Bayesianism there. However, you do find claims that he believes his theories. He says as much. This is completely unlike what Popper implored us to do and what physicists like Michael Faraday thought. Michael Faraday said something to the effect of, "I hold my theories on the tips of my fingers so the merest breath of fact will blow them away." So he understood testability. He understood that you can have your theories all day long, but once the observation comes along and it refutes your theory in light of a better theory, well, so much for having believed your theory. There's no need to believe your theories. Scientists shouldn't believe their theories. It's the wrong epistemology. It's the wrong way of going about science. Science explains the world through misconceptions. We say misconceptions because we should expect our theories to contain some error, not to be the final word on things. And because there's an error there, they'll be fixed one day, overturned, and we'll look back and go, well, that was a misconception. Useful as it was to solve problems and getting something right about the world, saying something correct, something true, containing truth, an explanation, but nonetheless, ultimately, in the final analysis, false, a misconception. So why believe it? Why think it's true? What does this word belief mean in this sense? What function does it serve? Once one begins believing things, one ceases to be a fallibilist. But then, of course, at other times, Max says, but we don't know for sure, so it's hard to know exactly where he's coming from. There's not a consistency there in the book. I've just released a podcast called Lookouts, and it's about worldviews. And it says why having a worldview, which in other words I would say, not only a rich, deep, foundational understanding of the science, but also having an understanding of what metaphysics is, ontology, epistemology, and how these things relate to everything else. Science, physics, mathematics. And how all of this can come to bear on broader, even more important things perhaps, like morality. And having a conception of all of these things that is encompassed by a philosophy of how to make progress, how to understand the world, and that we don't get to final answers. And the problem with thinking that one can get to final answers rather than simply improve continuously over time. I'm just going to read an excerpt from page 880 from Our Mathematical Universe. This is chapter 12. So it's a big tome all about the different levels of multiverse. And he says, this is Max Tegmark speaking, quote, "Interestingly, in the context of the mathematical universe hypothesis, the existence of the level 4 multiverse isn't optional. As we discussed in detail in the previous chapter, the mathematical universe hypothesis says that a mathematical structure is our external physical reality, rather than being merely a description thereof. This equivalence between physical and mathematical existence means that if a mathematical structure contains a self-aware substructure, it will perceive itself as existing in a physically real universe, just as you and I do, albeit, generically, a universe with different properties from ours. Stephen Hawking famously asked, what is it that breathes fire into the equations and makes a universe for them to describe? In the context of the mathematical universe hypothesis, there's no fire breathing required, since the point isn't that a mathematical structure describes a universe, but that it is a universe. Moreover, there's no making required either. You can't make a mathematical structure. It simply exists. It doesn't exist in space and time. Space and time may exist in it. In other words, all structures that exist mathematically have the same ontological status, and the most interesting question isn't which ones exist physically, they all do." End quote. So, as I say, that's from chapter 12, and it's from a section in chapter 12, the title of which is, and I'll read you the title, "Why I Believe in the Level 4 Multiverse." So I think that's just a departure from science, I'm afraid to say. It's somewhat a departure from rationality. He calls what he's doing the mathematical universe hypothesis, yet he says he believes it. Why? What is the rational reason? We're not given one. We're told that all mathematical structures just exist. Now, this is confusing necessary truth with our knowledge of the necessary truth. He's saying that he's gotten to the ultimate final truth. And that truth is that the entire universe consists of mathematics. In fact, there are an infinite number of universes out there that are made of mathematics. But what privileges mathematics? What makes the difference between the abstract mathematical objects and the abstract any other objects? The difficulty for Max fundamentally is that he cannot get outside of his physical brain. Now, he argues in a circular way. He says that everything is mathematical. It's Pythagoras' idea. All is number. He begins with that assumption and then reaches that conclusion in the end as well, rather than starting with problems. For example, what is the brain? Figuring out, well, okay, the brain is made of neurons. What are neurons made of? They're made of atoms. Okay, that's a form of matter. What are the laws that matter must obey? Well, quantum laws of physics. Are the quantum laws of physics computable? Indeed they are. And indeed all physical structures undergo physical processes themselves which are computable. And that includes brains. That includes brains that do mathematics to come to an understanding of mathematics. However, what we also understand via this process, via this understanding of computational universality, is that computers can introduce errors. They're not perfect machines. They can error correct. But there's no getting around the fact that it could be the case that a mistake is made at any point during the explanation, the computation, the calculation, however you want to put it. A neuron can misfire. An electron can go the wrong way. A person can just make a mistake. And that cannot be escaped from. And that includes any conclusion reached by that brain, or mind, we should say. And that includes minds that come to the conclusion that, for example, everything is made of maths, that everything consists of mathematics, and therefore level 4 multiverses exist, don't necessarily exist, must exist. But this has all been arrived at via a brain obeying the laws of physics, via something we know. We know that. And so we know that it can't be the case that we can simultaneously know for sure that the mathematical universe exists, as in the mathematical multiverse that Max Tegmark says exists. So what I'm sad to say is he is ignoring known science. It's true for him to say it's a mathematical universe hypothesis, but it is irrational for him to say that therefore he believes it. A scientist shouldn't believe their own theories even when they're known, when they are the best explanations. But in this case, we don't even have a known theory. It's not even a good explanation. It's just one explanation among many to solve certain problems. Those problems I've already mentioned are just things like the fine-tuning issue, the fine-tuning problem. But what Max wants, and this has been true across the eons, is a certain foundation that explains absolutely everything once and for all. It's a kind of religious notion, this idea that, God created everything and that, the ultimate answers are held by God and there's nothing beyond that. Well, the mathematical universe, especially the level 4 multiverse, is that structure. It is that thing. It serves that purpose. It answers all questions. Let's just go on a little further, and I'll just read from page 959 of his book. And he says, quote, "The level 4 multiverse does not imply that all imaginable universes exist. We humans can imagine many things that are mathematically undefined, and hence don't correspond to mathematical structures. Mathematicians publish papers with existence proofs that demonstrate the mathematical consistency of various mathematical structure descriptions precisely because to do this is difficult and not possible in all cases," end quote. Elsewhere, when Max writes on this, he does speak in terms of all conceivable things exist. If you can conceive it, then it exists. But now he's saying that not all imaginable universes exist. Maybe what he means, or should say when he's speaking more carefully, is that all conceivable mathematical structure exists out there somewhere or other. But as I also pointed out during this podcast, in other universes with different laws of physics, if there are people in those universes with different laws of physics, then they are able to prove different things about different mathematical structures. And so their conclusions that they reach about this level 4 multiverse, if it exists, would be different to ours. So whatever he's saying about the level 4 multiverse here, by his own reckoning, should be different in other parts of the level 4 multiverse. So what do we say? Whose level 4 multiverse is it? Is it constrained by the mathematics that's known here or known there? Or rather provable here or provable there? We can't say. It's not easy to know. I don't know if the question is well defined either. It's true to say that logic is logic is logic and mathematics is mathematics is mathematics, regardless of where you are. But assertions about what mathematical structures exist based on what human brains can do, trying to reach conclusions about places where the physics is so different that what can be understood by mathematics is literally inexplicable to us because our brain simply is unable to grok stuff that brains presumably obeying completely different laws of physics are able to grok. Well, we're getting into the intractable area of metaphysics and fantasy. So it's very difficult to talk about these things. And this is why it would be strange for me to hear someone say they believe this stuff. But his problem is, and what he can't escape from, is he's making claims about this level 4 multiverse, in this sense at least, where he said it doesn't imply that all imaginable universes exist. We humans can imagine many things that are mathematically undefined and hence don't correspond to mathematical structures. So he's saying that if they're not mathematically defined here by us, presumably by our mathematicians, then they won't exist in the level 4 multiverse. But our capacity to imagine stuff is constrained by our brain that obeys these laws of physics here. If the laws of physics elsewhere are different in the level 4 multiverse, which by definition they will be, then there will be people there whose brains are operating on laws of physics that allow them to compute and hence to imagine structures that we can't imagine. So he's contradicting himself. This itself doesn't make any sense. This is an incoherent notion, which is a problem for the level 4 multiverse, much less believing in such a multiverse based upon this argument. These are the kind of discussions people have when they've had too many beers or smoked too much weed, I think. It is metaphysics. It's not constrained by what we know. But if you want to have this sort of discussion, it should at least begin in what we know. And what we know at the moment are laws of physics, to the extent that we know them, our best explanations. This is why explanations need to be at the center of our concern about rationally understanding the world and having rational discussions and writing popular science books. Now, finally, I'm just going to skip way back to earlier in the book, earlier in Our Mathematical Universe, where he mentions Popper once. And as you can guess, as we always say here, whenever I pick up a popular science book, whenever I listen to a podcast, whenever I tune into a YouTube explainer video and Karl Popper comes up, it comes up in the same way. And it comes up in such a way that it's a misconception. It came up during their conversation. Let's see what Max has to say in the book itself, because it comes to bear on what he thinks about testability. Now, he doesn't even think, as I think many others have said before, I think Sean Carroll has said, even though these guys ostensibly endorsed the multiverse, the many worlds interpretation, Everettian quantum theory, they don't think it can be testable. Well, Max goes even further. He doesn't think that it needs to be testable. He doesn't think, not only does he not think it is testable, he doesn't think it needs to be testable or should be testable, because he doesn't think multiverses in general need to be testable. And he says this because he claims multiverses are not theories in the first place. And Popper, he claims, when talking about testability, was only talking about the testability of theories, not predictions. And the multiverse, he says, is a prediction from a theory. Now that's very cute, but it's completely wrong. But let me just read from page 346 of his book. And he says, quote, "Let's be more specific. The influential Austro-British philosopher Karl Popper popularised the now widely accepted adage, quote, 'If it's not falsifiable, then it's not scientific,' end quote." And he goes on to say, "Physics is all about testing mathematical theories against observation. If a theory can't be tested, even in principle, then it's logically impossible to ever falsify it, which, by Popper's definition, means that it's unscientific. It follows then that the only thing that can have any hope of being scientific is a theory, which brings us to a very important point. Parallel universes are not a theory, but a prediction of certain theories," end quote. Well, look, It's true to say that the claim of anything like X exists is not falsifiable. And Max uses the existence of a banana to point this out. Also, just after this, he goes on to say, quote, "Parallel universes, if they exist, are things, and things can't be scientific, so a parallel universe can't be scientific any more than a banana can," end quote. I don't know what that means. Anyone who claims bananas do not exist has a falsifiable claim. So he's completely confused about that. And he's confused because he does not understand the criterion. And he doesn't understand the criterion because he hasn't read Popper, is my guess. Or if he has, he's misread him. I mean, Popper wrote whole books, many of them explaining his stuff. It's a whole thing. It's not just, quote, "if it's not falsifiable, then it's not scientific," end quote. But, you know, as I say, this is what passes for Popperian epistemology in some places. If someone says bananas don't exist, pull out a banana and go, "There you go, it's a banana." You've falsified their claim. Or, "There are no bananas in this room." Pull out a banana. Now, if they still deny it, well, then you're in the presence of an irrational person. That's how falsification works. The thing is, one better way of understanding Popper on this point about testability or falsifiability or theories and predictions or whatever is just to begin with the assumption what we're doing is conjecturing. We're guessing at reality. We're interpreting stuff. And on that basis, theories and predictions are conjectures. They're all conjectures. It's all conjectural. It can all be tested. Of course the predictions can be tested. Of course the predictions can be falsified, gainsaid, shown to be false, shown to be wrong, refuted. They're a way of interpreting a consequence of a particular theory. David Deutsch actually describes, and in my Multiverse series I spend some time explaining the way in which he would set up an experiment, a possible experiment, to distinguish the so-called multiverse interpretation, the multiverse theory, as compared to collapse models, right? The standard Copenhagen interpretation, this idea that the wave function collapses or some such, that there aren't multiple universes, okay? There is such an explanation that can be done. I don't want to go through it right now, but it will involve an AGI, one day the future existence of an AGI able to perform an interference experiment in its own brain, okay? This sort of thing could be done. But also, any test of quantum theory is a test of the multiverse because they are one and the same thing. And that's what we should be saying if we're going to properly explain these things. So even the defenders of multiverse theory are not doing themselves a favour by claiming in some way, shape or form these things aren't testable. They are. They are. This is why Popperian epistemology is important. This is why having a coherent worldview, as I say, is important. Why having an understanding of how the philosophy gives you a certain kind of epistemology. And the epistemology tells you about the limits of knowledge, what can be known and the way in which it works, certainty and uncertainty. It tells you about mathematics and why mathematics, although it's about necessary truth, it doesn't allow you to access certainty and the absolute truth of anything. It doesn't put hierarchies there in place between science and mathematics. It also doesn't allow you to know the ultimate nature of reality. And it also tells you why that's not even desirable, because we want progress and we want optimism, and this idea that there is an end point in some way, shape or form to our understanding this ultimate nature of reality is a depressing thought. It also means that you end up with dogmas and doctrines, and the idea that the truth is manifest ends up leading to tyranny. So we've got a connection there with morality and politics. It's all encompassing. This is why we like to explain the worldview that's in the beginning of infinity and the fabric of reality and elsewhere. It provides you with this. We're not just saying it has all the answers, but it has some sort of coherent framework which allows you not to make what I regard as clangers of logically inconsistent claims and pseudo-scientific, religious, metaphysical claims as well. None of this is to say that overall this is what Max is doing. He's not. Okay, the overwhelming majority of the book is good, but I think it's just undermined by not having a deeper understanding of philosophy and epistemology. You can't do away with these things. I don't think a philosopher should ignore physics, the most important sorts of physics, things like consequences of quantum theory. I think that's just really important to do. Mathematicians shouldn't ignore it as well. None of them should ignore epistemology. Anyone who's versed in epistemology should have some understanding of science. It's not to say one needs to be an expert in all of these things. It's just helpful. It helps to make progress in any one of these areas if you're an expert in one of them by knowing a little bit of the rest. It helps everyone just to know a little bit. But that's the multiverse according to Max Tegmark, or the multiverses according to Max Tegmark. Next time we're going to be talking about minds, and I'm going to pick it up where, at the end of this conversation, they talk a little bit about AGI. And then their next conversation that they have is entirely devoted to AGI. And they're basically in furious agreement about things and about the dangers, the potential dangers of AGI, and just not really understanding that AGI would be a mind like ours, able to universally explain stuff like we can, to be creative like we can. Instead, of course, they make that error of, well, it might just have different goals and it would disregard us, it'll have worse morality, all this sort of stuff. So, we'll leave that until next time. And until then, bye-bye.